Our next topic we're going to be talking about is solving radical equations and inequalities. We are first going to solve with radical equations. So, an important thing to always remember when we are solving radical equations and inequalities is you need to make sure to check your answers. It's super important because sometimes when you figure it out, it might not actually be the correct solution. So, in the problem below, 5 equals the square root of x minus 2 minus 1, we are simply going to solve for x. So, our first step should be to add 1 to both sides. 5 plus 1 is 6. And on the other side, I'm left with the square root of x minus 2. Now remember, the opposite of square rooting is to square both sides. Once we do that, we have 6 squared, which is 36. And our square root and our squared cancel, and we're left with x minus 2. We still want to solve for x, so our next step would be to add 2 to both sides. So we would have that 36 plus 2 is 38, which equals our x. Now remember, we need to check our answers. So we're going to plug x in wherever it is in our original problem. So we have 5 equals the square root of x, which is now 38, is what we found, minus 2 minus 1. 5 equals 38 minus 2 is 36, still at minus 1. The square root of 36 is 6 minus 1. So we have 5 equals 6 minus 1, which is 5. So since it checks out, we know that 38 is actually our answer. This next example is solved a little bit differently. Notice we have 2 square roots in this. So our first step is to actually, while we're still solving for x, we need to square both sides. When we square the left side, we're left with just a simple x plus 15. But when we square the right side, we actually get 2 terms of the 5 plus the square root of x. So, we're going to need to FOIL these, or double distribute. So I'm actually going to get 5 times 5, which is 25. I can't write today. And then I get positive 5 square roots of x. And then I get another plus 5 square roots of x. And then I get square root of x times square root of x, which is actually square root of x squared, which simplifies to just positive x. Okay, simplifying it down, I still have that x plus 15 equals 25 plus 10 square roots of x plus x. I'm going to subtract the 25. So I have x 15 minus 25 is a negative 10 equals my 10 square roots of x plus x. I'm going to subtract the x over, and when I do that, these x's cancel, and I'm left with negative 10 equals 10 square roots of x. My next step is to divide both sides by 10. So I get negative 1 equals the square root of x. Now, my last step to get rid of the square root is to square both pieces. Negative 1 squared is positive 1, which equals x. My next thing I want to do is check my answer. When checking your answer, we had negative 1, which equaled our square root of x, so our x just equaled 1. So to check our answer, we want to plug 1 back into our equation and see if it makes sense. So we have the square root of 1 plus 15 equals 5 plus the square root of 1. 1 plus 15 is 16, and the square root of 16 is 4. 5 plus the square root of 1, the square root of 1 is 1, so we have 5 plus 1, which is actually 6. 4 does not equal 6, so this is not our solution. So in this problem, our answer would just be no solution. That's why it is important to check your answers. This problem looks a little bit different because we have something raised to the 1/3 power. Remember, that's like taking the cube root of something. So in this case, we do the same thing. We want to solve for n. So my first step would be to subtract 1 over. So I have 3n plus 2 all to the 1/3, which gives me -1. Now if you think back all the way to our first lesson, when we raise something to the 1/3 power, to get what we want back, we need to cube it in this case. If it's raised to the 1/3, we want to cube both pieces. So our 1/3 and our cube cancel or divide to 1, and we're left with just that 3n plus 2. Now, -1 to the 3rd, remember, is actually -1, because when you have a negative cubed, it's actually a negative. So to continue solving for n, we're going to subtract 2 over. So we get 3n equals -2 minus 1, which is a -3. Divide both sides by 3, n equals -1. Now remember, we need to check our answer. So I have 3 times 1 plus 2 all to the 1/3 power plus 1, and that should equal 0. Remember, this is a -1. I forgot my negative sign there. So 3 times -1 is -3 plus 2. -3 plus 2 is -1 to the 1/3 plus 1 is 0. -1/3 to the 1/3 is actually -1. Plus 1 is 0. And -1 plus 1 is actually 0. So that works. So that means our answer is actually -1. In this problem, we actually want to solve for x again. And it's to the 1/4 power, or this would actually be the 4th root. So our first step should be to add 12 to our other side. So I have 4 times 3x plus 6 all to the 1/4 equals 12. My next step is to divide by 4. I get 3x plus 6 to the 1/4, which equals 3. Now, remember, if something is raised to the 1/4, to get rid of it, we want to times it by 4 so it cancels. So 1/4 to the 4th power cancels or divides to 1, and I'm left with 3x plus 6, which gives me 3 to the 4th power, which is 81. I need to subtract 6 to both sides, so I have 3x equals 81 minus 6 is 75. Whoop. And divide both sides by 3. X would be 25. Now I need to check my answer. So I get 4 times 3 times 25 plus 6 to the 1/4 minus 12 equals 0. 3 times 25 is 75. So I get 4. 75 plus 6 would give me 81 to the 1/4 minus 12 equals 0. 81 to the 1/4 is 3. So I'm left with 4 times 3 minus 12. 4 times 3 is actually 12. 12 minus 12 is 0, so we know that 25 is actually our real solution. Inequalities can be a little bit different. A couple things we want to note. When we solve radical inequalities, if the index of the root is even, identify the values of the variable for which the radicand is non-negative. Then we need to solve the inequality algebraically and test values to check your solution. So once again, we're checking our solution. You solve these exactly the same way as you would solve an equation, you just now have an inequality. the step 1, if the index of the root is even, will apply to our next example. In this example, we have a greater than symbol, so our inequality will be solved exactly like an equation would. We don't have to worry about the radicand. So let's solve this. So first step, we're going to subtract 1 over. So I have the square root of 2x plus 2 is greater than or equal to 4. My next step, like always, is to square so I can get rid of the square root. That cancels, so I'm left with 2x plus 2 is greater than or equal to 4 squared, which is 16. I want to subtract 2, and I'm left with 2x is greater than or equal to 16 minus 2 is 14. My last step is to divide by a positive 2, so I'm going to have x is greater than or equal to 14 divided by 2, which is 7. Once again, I need to check this solution. And now I want to plug in a number where x is actually greater than 7 or equal to 7 so I can see if this inequality makes sense. So I'm going to choose 8. So let's see if this works. So I have 2 times 8 plus 2. You can pick a different value than 8 that might work out better for your inequality. So you have a perfect square. But I have 8 times 2 is 16 plus 2 is 20. So I have the square root of 20 plus 1 is greater than or equal to 5. The square root of 20 is roughly 4.47. And I still have that plus 1 is greater than or equal to 5. When I add this, 4.47 plus 1 is 5.47, which is greater than or equal to 5. This is a true statement, so I know that x greater than or equal to 7 is actually a true solution. In this example, since we have a less than sign, we need to worry about the radicand. Now, the radicand is what is underneath the radical. So in this case, my radicand would be 4x minus 4. And I need to set this greater than 0 and solve for it. So if I add 4 to both sides, I have 4x is greater than 4. Divide by 4, x needs to be greater than 1. Okay, so we need to keep this in the back of our mind when we work on this problem. Now we can solve this problem normally. We want to add 2 to both sides, and I have the square root of 4x minus 4 is less than 4 plus 2 is 6. Square both pieces, and I have 4x minus 4, because these cancel, is less than 6 squared, which is 36. Add 4 to both sides, and I have 4x is less than 40. Divide by 4, x is less than 10. Now, one thing to remember too, when we had that x was greater than 1, it's actually greater than or equal to when we solve for the radicand. So, my solution set says 1 is less than or equal to x, which I have here, and it is less than 10. So x is greater than or equal to 1, but less than 10. So now I actually need to check my solutions. I'll need to check a number that's below 1, that's in between 1 and 10, and that's above 10, so I can figure out what my solution is. So let's do that. Let's first plug in 0. So if I plug in 0 to my original equation, 4x, so it would be 0 minus 4 is negative 4, and the square root of negative 4 is actually an imaginary number, so we know that won't work. So we know that we can't have any number that's less than 1, so this side won't work. Let's pick a number on in the middle. Let's try 2. 2 times 4 is 8. 8 minus 4 is 4, so I have the square root of 4 minus 2 is less than 4. The square root of 4 is 2 minus 2 is 0 is less than 4. This is correct, so I know the middle of my solution is correct. We need to check one more number. Let's try 11. 11 times 4 is 44, minus 4 is 40. The square root of 40 is 6.32 roughly, and then we need to subtract 2. So my answer is 4.32 is less than 4. Well, that's not correct either. So when I try 11, that doesn't work. So I know that my solution has to be in the middle. So my answer really is 1 is less than or equal to x, which is less than 10. So the most important thing to remember when solving equations and inequalities for radicals is to check your answer to make sure your solution works and makes sense.